Hello everybody and welcome back to Operation Logistics, where we're missing a curly brace. There we go. Okay, that's a little bit better. So we need to set the box collider position and extents according to I and I-1, with our I, of course, being our list of our line. So we need to set our positions here, and this is, of course, in our waypoint for our line renderer. Essentially, we are setting up... Well, let me just come on in here and demonstrate again. We've got this, and realistically, we would then add another box collider for our second segment. And this second box collider would be the same size-ish. However, we don't actually have the ability to rotate the box collider here. So what we should actually be doing, probably, is creating an empty inside of here. And then with that empty, we should be adding in this box collider. So we would then copy this component, remove this component, and then we would paste this component as new, like so, and then we would duplicate this object. In the code, we'd probably just instantiate a new one, but we'd duplicate this object, and then we would leave this pretty much the way it is. And we'd position it to be right about here, right at, well, technically right at where this point begins. So 1.5. 1.5. Okay, and we should be not in orthographic mode for right now. And I just want to... It's so small, I can't hardly see. I just want to check our heights here. The height seems fine, honestly. Okay. And then from up here, we'd basically just need to rotate this, right? So we would rotate it on the y-axis like so. Technically, this is what, probably 55 degrees, thereabouts? That's not quite right. It's a hexagon, right? So it's 60 degrees. Oh, that's too much, too. That's interesting. Well, we'd find the angle between these vectors, anyway, and make the forward vector be pointing directly down along this, which is about that. And then we would just adjust the length. No, that's the width. We would adjust the length. There we go. Up until it reached that point. However, it does seem to be increasing proportionally, doesn't it? It does. That's a little unfortunate. I would prefer that it not be doing that, realistically. So with this game object, I think we're going to go ahead and need to position this exactly at 0, 0, 0, right at where the game object actually lies. And then we'd need to bring up the game object to this 0.51, like so. And then we need to offset this based on half of the x size, so 0.33, no, half of the y size. What am I talking about? 0.05, which we would do... No. What am I talking about? I have no idea. It's 0.75 on the Z. Okay, there we go. So we've got that output then. And then we just get the length that way, and then we would get the rotation. But now, theoretically, I think, as long as we keep adjusting this, so like, for example, if this is a length of 3, we would need to then just adjust the offset to 1.5 to ensure that we remain at our origin, so that we can then just rotate it as necessary. Now, the other thing that I want to check here is this actually... I don't think it is actually properly set up here. So, like, the position of this here is negative 0.3. But the axes here are really, really weird. Okay, that's good to know. Yeah. So I mean, for now, this'll be fine. We just need to make it so that we are creating an empty, and we can go ahead and delete this for now. So here's essentially what we're going to be doing. We can go ahead and pull back open the waypoint here. And we are actually not going to be using this line here. First thing that we're going to do is we are going to create a new game object. Now, to do that, we probably want to just instantiate a new game object. So we'll go with game object go equals instantiate. Can we do new game object? We can. What's this error? Oh, of course. We need our parentheses. Yeah, that actually seems fine. So the parent would then be this.transform. Do we instantiate it in world space? I don't think so. I think we do want this.transform. We can set the position ourselves. Quaternion rotation. Can we just leave it at this? We can. Okay. So we go ahead and instantiate a new game object. And then from that, I'm going to go ahead and say go.name equals, and we're going to name this collider. We'll call this line, and this will need to actually be a string.format. So we'll string.format this, not formate, format. And we'll go ahead and call this line segment 0, not 9, 0 collider. And then we'll go ahead and pass in I. Okay. So that should go ahead and toss that in. Although, maybe we want to have this be I+1, have it 1 indexed. I think it's fine to have it be 0 indexed. Okay, so we've got our game object. Next, we need to go ahead and add in this box collider. And we're going to add that not to this game object, but rather to Go. Excellent. Okay. I've never actually done instantiate new game object before, so we'll see if that actually works. I think that's just going to create an empty, but we'll see. And then we need to set the box collider position and extents according to our positions. According to I and I-1. That isn't how this works. It would be according to I and I+1. Because we're doing line.count -1, we are guaranteed to not go out of scope here, so that should be fine. So yeah, we just need to set the position and extents. I think we can safely hardcode in some of these. So I'm going to undo this deletion here. We can safely hardcode in this size here of 1.5 on the Z. We'll be able to change that later on, but 0.33, 0.1, and 1.5 will be good. So we'll set the initial size of the collider. Col.size equals new vector3, and this was 0.33f, 0.1f, and 1.5f. Okay. So there's our initial size. Next, we need to set our center, which will, of course, be 0, 0, half of our z. Now, we'll do that at the very end. So, col dot... what's the variable called? The variable is called center. So, col dot center equals new vector3. This will be 0, 0, and then half of col.size.z. So col.size.z divided by 2f. There. Okay, so with this being the case, that's going to be basically the last thing we do. because we're going to be messing with the size and the rotation and such. So then we can just go ahead and say something along the lines of finalize the center point of the collider. Okay. We are also going to need a public void. Actually, this doesn't even need to be public. Private void, and this will be on mouse down, probably. On mouse up as button? What exactly is that? Only called when the mouse is released over the same GUI element or collider as it was pressed. That's actually a neat little feature. I didn't realize that existed. We're going to do on mouse down for now, though. And then we're just going to do something along the lines of if input.getMouseDown, mouse button down, 0, debug.log, and we'll just output left mouse clicked on waypoint. That's all we'll do for now. And then an else if input. So the left mouse is going to have priority here for now anyway. Get mouse button down 1. Then we can go ahead and debug.log right mouse clicked on waypoint. Waypointing, apparently. There we go. Okay, so we now need to set the box collider position and extents according to I and I+1, but we don't actually need to do that, do we? What we really need to do is we need to rotate the box collider, rotate go.transform, technically, to fit the vector of the line segment. Or, well, instead of calling it vector, we'll call it rotation. Rotate go.transform to fit the rotation of the line segment. And then the other thing that we need to do is set the final size of the collider .z to be the length of the line segment. Okay, so essentially what we're going to do that is we're going to say col.size, and I don't think we can do this, right? Yeah, cannot modify the return value of size.z. It's a little bit unfortunate, but what I'll go ahead and do is do a vector3 col size equals new vector3, and this will be essentially just this vector3 here, so that we can accidentally hit Control-C instead of Control-V there, so that we can mess with this, and we will set this later on. So initial size of the vector, and then we can do col size.z equals length of the line segment, which we'll do here in a moment. Of course, this isn't going to compile, but that's fine. And then we will finalize the center point and size of the collider. We'll want to do the size before we do the center, since the center is based on the size. So col.size just simply equals col size. Okay. Now we'll grab the length of the line segment here quick, which is going to be I and I+1. So this would be from I to I+1. So line I minus line I+1 dot magnitude. Now that's going to be a bit slow there, but we do actually need to know the actual length of it, and theoretically, as long as we don't have ridiculously long roots, it shouldn't be too bad. And as long as we're not updating this line too frequently, which we shouldn't be. Okay, so all we need to do now is rotate go.transform to fit the rotation of the line segment. And we know for a fact that our Z line here is the line that we want to be facing the next point. So this should actually be as simple as a transform.lookAt, right? So go.transform.lookAt rotates the transform so the forward vector points at the target's current location. Now, the forward vector is the blue axis, which is the one that is our forward vector. So this should be as simple as transform.lookAt, and then we look at line I plus 1. That should be it. Okay. So with that being the case, we still have a lot of work to do on these routes, of course. So we've got all of this going on here. And then we, I think, basically have our routes spawned in here. And then we need to figure out how exactly we're going to go about doing the creation and editing and such. But that's something for another episode. I'm going to go ahead and put a cut in here, and next episode, we will continue working on routes. See you all then.